Alright guys, so we are going to continue working with blood, and we're going to look at blood spatter evidence. And blood spatter are the patterns left by falling, projected, or smeared blood, and these can be used to interpret or reconstruct what has happened at the crime scene. So we could possibly get clues of how many people were at the crime scene, how the blood was deposited, if there were weapons, we might see different blood spatter patterns and things like that. A lot of times these can be used to prove or disprove a suspect's account of what happened. If they're saying they saw 2 people there, but we have 3 different sets of bloody footprints, that would discount the witness statement. Or maybe we could figure out if a certain type of weapon was used, or if they said it was a gunshot, but the blood spatter does not match up with a gunshot wound. An observation of the position and shape of blood patterns can be used to find the direction of travel, the angle of impact, the position of origin, and the speed of impact. So these are going to be some things that we can figure out based off of what evidence specifically we find. So we're going to be going over some different types of blood spatter patterns that we look at. And these are alphabetical, so some of them we will refer back to as we go through these. But when looking at describing blood stains, one thing that we're going to look for, and we're going to calculate this in a little bit, is we can look for the angle of impact. This is an acute angle, so it's less than 90 degrees. So it's the acute angle formed between the direction of the blood drop and the plane of the surface it strikes. So you can see this in the picture in the bottom left, that there's a blood droplet traveling, and we're measuring the angle at which it hits the floor or that surface. We also can encounter arterial spurting patterns. Arteries are larger within our bodies, so they carry a larger volume of blood. So if an artery is breached, a lot of blood is coming out in a short period of time. So an arterial spurting pattern is a blood stain pattern resulting from blood exiting the body under pressure from a breached artery. And every time your heart beats, it will spray blood out. So this is shown in the picture in the middle, where it's a very irregular pattern. So notice that you have spots that have a lot of blood and then gaps. It's because every time your heart beats, it would spray blood and then pause, spray blood and then pause. And with gunshot wounds, we're going to have forward spatter and back spatter. So I'll refer back to this diagram in a moment. But back spatter is blood directed back toward the source of energy or force that causes the spatter. So this would go back toward the shooter themselves. So here in the image, you see there is a gun, there's a bullet going through the head, which is the circle in the middle. Notice that there is blood right here that is going back towards the weapon or back towards our shooter. So this is one thing that they can tell, and this is why shooters often have traces of blood on them, depending on how close they were to the victim. Blood spatter analysis is a field of forensic science that deals with the physical properties of blood and the patterns produced under different conditions as a result of various forces applied to the source of blood. So there are individuals that actually study blood itself. They look at how it moves, its thickness, if a certain weapon is used, how the pattern changes from one weapon to another. So there's a whole field of forensics that solely studies the pattern of these blood spatter. A blood stain is evidence that liquid blood has come in contact with a surface. This could still be wet or it could be dried blood. But it's one of those things that even if someone tries to clean up a crime scene, we may still be able to find these stains and find these traces. One spatter pattern that gets used pretty often are cast-off patterns. These are bloodstain patterns created when blood is released or thrown from a moving blood-bearing object. So if someone is hit in the head with a baseball bat, and then the baseball bat is pulled back and then swung again, that motion of pulling the bat back or swinging it again, blood droplets are going to get flung off from that weapon. So you can see that in the picture on the right of when the bat is being swung, there are going to be blood droplets that are flung off of it. This we could also use to possibly determine the type of weapon used. And a lot of times it helps us determine the thickness of the weapon. So there are cast-off patterns shown on the left. The top one is from a lead pipe. The bottom one is from a pool cue or a pool stick. Pool sticks are thinner than pipes generally. So if you notice, the thinner weapon on the bottom has smaller droplets and they are not spread out as much. So someone who looks at blood and looks at these patterns would be able to recognize that there's a different thickness in these weapons. We also have contact stains. This is blood deposited from direct contact between two surfaces, at least one of which is bloody. So we have seen these with our impressions. So this might be a bloody shoe print, a bloody fingerprint, where someone stepped in blood and then they continued to step and deposited blood with each step that they took. With blood, we can also determine the direction of flight. This is the trajectory of a blood drop, which can be established by looking at its angle of impact and its directionality angle. So we already said angle of impact is what angle it comes in to hit the surface, but we can also look at the direction. And the directionality is the pattern that indicates the direction blood was traveling when it hit the target surface. So in order to tell the direction of a blood stain, we're going to look at the tail that gets given off of it. So if you look at these images in the middle, notice there's a blood drop and there are these tails that come off of the blood drop. Whatever direction that tail is pointing is the direction the blood was traveling, because the main blood drop will hit the surface and a little bit of the blood will continue moving. If the blood drop is truly circular, like this one on the right, that indicates that there's no direction. It was dropped from straight down, versus if it's coming in at an angle or from the side, it will have a tail and be elongated more like a teardrop versus a circular droplet. We also have drawback effect. This is another thing that we will see with gunshots. Whenever a gun is fired, there is air pushing the bullet out of the gun. Once the bullet leaves the barrel, air gets sucked back into the barrel of the weapon. Well, when that happens, if there is blood in the air around the weapon, that blood can be sucked up into the barrel of the firearm and get drawn back into the muzzle. So even if someone commits a shooting, they clean the outside of the weapon, there might be traces of blood on the inside of the weapon from that drawback effect. We also have drip patterns. These are bloodstain patterns that result from blood dripping into other blood. So this might occur if someone cuts themselves and there's blood dripping from their arm or something like that. When blood drips into other blood droplets, it will create these sprays that go outward. So you can kind of see this pictured in the picture on the left. we have multiple blood drops that hit onto one another, and we get all of these tiny droplets that are sprayed off in every direction. We also have expirated blood. This is blood that is blown out of the nose, mouth, or a wound as a result of air pressure or airflow. This, a lot of times we might see if someone has a punctured lung, the air coming out of the lungs can spray blood out of a wound. If someone gets hit and they have blood in their mouth and they spit that out, that is considered expirated blood. Or if someone has a bloody nose and they try to blow it out of their nose, that is considered expirated blood as well. We also encounter flow patterns. This is going to be due to gravity, but it's a change in the shape and direction of a blood stain due to the influence of gravity or movement of an object. So here you can see there was blood deposited on the wall, and gravity causes these trails to move downwards and simply pull blood down in a stream. This could also happen if blood is on the outside of a car and the car drives off. The air moving past the car causes it to trail just like this. A moment ago we talked about the back spatter that goes back towards the shooter. There's also forward spatter with gunshot wounds. This is blood that travels in the same direction as the source of energy or force that caused the spatter. So here the bullet is traveling from left to right. So when the bullet goes through the head, it is this blood that exits out the back of the head that is going in the same direction as the bullet. We mentioned that you could tell the speed of the impact by the blood droplets. Here on the right, we have high velocity impact spatter, or HVIS. This is bloodstain patterns caused by a high speed impact or force to a blood source, like a gunshot, something that is very high powered, moving very fast. The velocity of these blood droplets can be 100 feet per second, and the droplets tend to be less than or equal to 1 millimeter. So this ends up resulting in a lot of very tiny droplets whenever it is a faster moving source. We encounter impact patterns. You may have seen an impact pattern whenever we mentioned the cast-off patterns earlier, but this is a bloodstain pattern created when blood receives a blow or force, resulting in the random dispersion of smaller droplets of blood. So this is where someone already has a wound from the first impact from a weapon, and then they are hit again with the weapon. And since there is already blood there, once it hits, it sprays out in every direction. This would be the same thing as someone jumping in a mud puddle. There's already liquid there. You jump in and it causes it to spray out in every direction. The impact site is going to be the point where the force meets the blood source. So wherever that wound is that is being hit with the weapon. We already mentioned the high velocity impact spatter. There's also low velocity impact spatter, or LVIS for short. This is a pattern caused by a low speed impact or force to a blood source. This might be something like a punch and things like that are not as forceful, not happening as fast as a gunshot wound, like with the high velocity impact. With these, velocity can be up to 5 feet per second, and here we get blood droplets between 4 and 6 millimeters. So it's a lower impact. The blood droplets tend to be larger and not as spread out as with the high velocity impact spatter. So that's what we're seeing in the picture on the right. In between those two, we have the medium velocity impact spatter, or MVIS for short. These are bloodstain patterns caused by a medium speed impact or force to a blood source, such as that should say beating or stabbing. Excuse me, that's a typo. So this might be with a knife, with a baseball bat, something like that. The velocity can be up to 25 feet per second, so it's a faster speed. And blood droplets can be anywhere from that 1 to 4 millimeter range, so between the other two. So the medium velocity is shown on the left. The droplets are smaller than the low impact, but larger than the high impact, and they're not as spread out as the high impact. With these speeds and forces, we can also encounter misting. This is blood that's been reduced to a fine spray as a result of the energy or force applied to it. Misting we tend to see with explosions and things like that, where it is such an extreme amount of force that it actually ruptures those blood vessels and the blood droplets. So this is what can be seen in the middle on the image of the right, where the blood droplets are so tiny, they essentially blend together. You may have seen this on movies and TV shows. If someone gets blown up, they refer to it as pink mist because it turns into such tiny droplets. There are also passive drops, which we tend to see when someone is bleeding and there's not necessarily a force applied. So these are bloodstain drops created or formed by the force of gravity alone. So this would be if you cut your finger and gravity is pulling blood droplets down and they hit the floor. With these, they do tend to be very circular because there's no force applied. It is not being flung off in a certain direction. Gravity is simply pulling it down. We have, with blood droplets, a lot of times they may cluster together. We have parent drops, which is our main or original blood droplet. So this would be a drop of blood that casts off a wave or satellite spatter. So these may have tails and things coming off of them. Satellite spatter are smaller droplets of blood distributed around a drop or pool of blood as a result to blood hitting a surface. So the middle image, you can see our parent blood drop, and some of the blood actually keeps going and disconnects to create a satellite blood stain. You can see that in the pictures on the right. There was a blood droplet that hit the ground, and we get these small droplets that spray off in every direction. Those are considered satellites. The tails of blood droplets, whenever they are elongated, are also considered satellites. Whenever we are trying to figure out where blood is coming from at a crime scene, we can look at the point or area of convergence or the point or area of origin. When we're looking at the point of convergence, this is the common point on a two-dimensional surface. So this might be on a floor or on a wall, looking at two-dimension over which direction several blood drops can be retraced. So this is shown in the picture on the left. Here we have a wall, and they are looking at the blood drops on the wall where they originated. So they kind of traced those tails, showing the direction back to where they all converged on one another. Excuse me. Whereas whenever we're looking for the point of origin, this is looking at the point in a three-dimensional space, so taking into account the whole room to where the trajectories of several blood drops can be retraced. So this not only looks at the direction that they came from, but also the angle those blood drops came from as well. And what they tend to do is they will use lasers or strings and have those strings going back at the same direction and from whatever angle of impact it was, and they'll look at in the three-dimensional space where all of those blood drops originated from. This can oftentimes help them figure out where a victim was or where a suspect was. And yet again, that can help them match up with witness statements and things like that. With blood drops, we also have spines. So these are still going to be attached to the parent blood drop, but it's going to be the pointed or elongated stains that radiate from a central area of a blood stain. So the satellite drops were detached from the original blood stain, whereas spines are still attached to the original blood stain. So you can see that in the pictures on the left. The spines are still attached to this blood stain. In the bottom one, the tail is still attached, so that would be considered a spine. If this part at the end separated, it would be considered a satellite drop. And then with contact stains, we can have wipe patterns and swipe patterns. Swipe patterns are a transfer of blood from a moving surface onto an unstained surface. And this would be where someone has blood on their hands and they wipe it down the wall. That is considered a swipe pattern, where you have a dirty surface coming into contact with a clean surface and there is movement. With this, the direction of travel can be determined by the feathered edge. It will be darkest where there is an original impact, and then it will lighten as the movement occurs. So you can see this in the middle image, where up at the top it is darkest, and then the hand moved down towards the right, and we see these feathered edges at the bottom where it is lighter. That's how we can tell the direction that is going. And with wipe patterns, it's a blood stain created when an object moves through an existing blood stain, removing it or changing its surface. So here you can see blood droplets and someone's hand move through pre-existing droplets. So we end up with a halo showing where the original droplet was, and you can see that the blood was moved or wiped up essentially. Where we mentioned contact stains earlier, a lot of times those can also be referred to as transfer stains or transfer patterns. These are patterns created when a wet, bloody surface comes in contact with a second surface. And a lot of times we're not just seeing that there was a foot that went through here, but we can actually see an image of the original surface that deposited the blood. So if you look at the two pictures in the bottom left, you can visibly see the shoe outline and the shoe tread in the picture on the left. And then the second image, you can clearly see someone's hand that was left behind after they touched that surface. Another thing that can give us clues is whenever we do not see blood droplets. So we do encounter voids. This is going to be an absence of stains in an otherwise continuous blood stain pattern. So it's essentially like a shadow where there was something there blocking blood, and then that object gets removed. So this could give us a clue of if a suspect was standing there and they got blood on them instead of blood getting on the wall behind them. We would essentially see an outline of their body. If we look at the third picture, there's blood droplets everywhere except for this middle region. And if we kind of trace that void, we can see that this is the end of a wrench, is what that would be. So there was a weapon there that was then removed. We can also see that in the picture on the right. Here was a hammer that was left here, and you can actually outline where the hammer was laying at the time that the blood was deposited. So like I said, that would give us a clue of if something was there and was removed from the crime scene, if someone was standing there and blocking the spray of blood. That could give us clues about what is going on. And analyzing blood patterns, this is going to be one of the activities we do after we get back. But like we said, we can find the direction of the blood droplets. So remember, whatever direction the tail is going would tell us the direction of travel. We can approximate the height by the size of the drops. So we'll do this in a lab later on. But generally, whenever drops come from higher heights, they tend to spread out more and be larger. We may be able to tell if the assailant is left or right-handed. We could give clues about this from cast-off patterns especially. If we know where the suspect was standing, if cast-off patterns are to the right of where they were standing, we could assume they are right-handed. If it's to the left of where they were standing, we could assume they were left-handed. One thing that we'll do after we'll get back, and this is something that you're going to be expected to do on your test and stuff, is find the angle of impact or impact angle. This helps determine that area of origin. And in order to find that, you have to measure the width and length of the blood droplet. And if it is a blood droplet that has a tail, we do not include the tail. So we would only measure the physical droplet itself and not that elongated part that's attached. So we would measure the width and length, and to calculate angle of impact, it is the arc sign, which is your sign -1 button on your calculator, and it's going to be the drop width divided by the drop length. And either they're going to be the same number or the smaller one always goes on top whenever we do math with this. And like we said, we're going to do an activity with this after we get back. That way you can practice measuring blood droplets and finding that angle of impact. But like we said, make sure it does not include any of those tails. It's only that main droplet. And we can find the origin, that area of origin, using triangulation. So this is where I said they'll look at the direction blood drops were traveling, as well as their impact angle, and they can use lasers or strings to trace back where those blood droplets came from. And wherever all the strings connect is the origin of those blood droplets. So that might be where our victim was initially. That's where we're stopping today. Hopefully we will be back tomorrow, and we will see where we can go from here.